Welcome back to another Math Notes video. Today you're going to need a purple sheet, a pair of scissors, and something to write with. Let's get started. The first thing you need to do is cut your note sheet just on this outside line here to get rid of that extra border. After you've taken that extra border out, you're going to go ahead and you're going to fold along this solid line right here. Once you've folded along that solid line, you're going to cut along this dashed line. You'll notice the dashed line only goes halfway. So it's dashed on this side and dashed on this side, but only halfway. So don't cut all the way through. Once you've cut, you should have two separate flaps. The next thing you need to do is take your flap and fold it to this edge here. Take the other flap and match it up as well. Go ahead and flip it over, fold in the opposite direction to make a nice crease. And we should be good to go. Here's a tricky fold, so watch this part carefully. You're going to open up the sides just a little bit to give it some space. Okay, so I can stick them out there. I'm going to take these two flaps and I'm going to pull them apart from each other very carefully and allow the rest of my sheet to bend in underneath. So right now I should have a diamond shape right here. I'm going to slowly start pinching closer and closer and closer until that diamond goes away. Now it should look like an X. Once you have this X shape, you're going to fold it in on a book. You want this solving systems of equations side to be the front of your book. This page is going to be the back. So as I'm here, I'm in the X. I'm going to go ahead and fold everything over so that I have my title page on the front, and then I can fold it over again so that I've got the front of my booklet, the back of my booklet, and when I open it up I should see a graphing, an elimination, and a substitution. Once we have our booklet made, we're going to go ahead and go through these three methods of graphing, elimination, and substitution. As a reminder, you can use all three strategies and they should all get us the same answer. So here are the equations we're going to work with today. The system has x minus y equals 4 and x plus y equals 2. When we're going to graph, the first thing we need to do is write the equations in slope-intercept form. This means that y is equal to mx plus b, where m is our slope and b is our y-intercept. For the first equation here, I notice that there's a negative y and I want a positive y. So I'm going to add the y to the other side. That would leave a 4 plus y on this side, and I need to subtract the 4 back. So I end up with an equation of y equals x minus 4. For the second equation, all I need to do is get rid of this x, so I'm going to subtract x from this side and this side. That's going to leave me with y equals negative x plus 2. The second thing we can do is, after we have them both in slope-intercept form, is we're going to graph them on the same coordinate plane. So this means for my first equation, I'm going to start down 4, and I'm going to go up 1 and over 1 because my slope is just x. For the second equation, I'm going to start up 2. And I'm going to go down 1 over 1 because I have a negative slope. For step 3, we need to find the solution. And the solution is the point where the lines intersect. So right here, they both crossed at this point right here, which would be the point 3, negative 1. So I can write it as 3, negative 1, or I can write it as x equals 3 and y equals negative 1. For our elimination strategy, this says to eliminate or cancel out a variable. If needed, multiply either, both, or neither equations by a factor in order to cancel the chosen variable. So I notice right here that if I would go to add these together right now and combine these equations together, that the negative y and the positive y are going to cancel out. So for this example, I do not need to multiply by anything. I'm just going to rewrite my equations, and then I'm going to add them together. When I go to add these together, I get x plus x makes 2x, and a negative y plus a y would be nothing. That part eliminates, so I'm not even going to write it down. Then I have an equal sign, and 4 plus 2 is 6. So I need to know 2 times what would equal 6. That means that x is going to equal 3. That's 1/2 of my solution. The second part says substitute the value of the variable into one of the equations in this system. So now I know that x is equal to 3. I can substitute it into either of these equations, but I'm going to pick the bottom one because there are no negatives in it. So instead of writing x, I'm now going to write 3, and then I'm just going to rewrite the rest of the equation. Plus y is equal to 2. So I need to know 3 plus what would equal 2. Well, I can also subtract 3 and subtract 3 to find that y is equal to negative 1. So again, both parts of these, the x and the y, are part of my solution. I can write it as 3, negative 1, or x equals 3, y equals negative 1, which is the exact same thing that we found when we graphed it. For our last strategy, we have this substitution method. The first thing we need to do is choose one of the equations and solve for a variable. That means we need to get one variable on a side by itself. I'm going to go ahead and choose this bottom equation here because, again, there are no negatives, and I'm going to get the x all by itself. In order to do that, I would have x plus y equals 2. I would need to subtract y to the other side and subtract y. That would leave me with x equals 2 minus y. Once I have a variable by itself, I can go ahead and substitute this expression, 2 minus y, into the other equation for that variable. So instead of writing x, I'm now going to write 2 minus y, and then I'm going to write down the rest of the equation. Minus y equals 4. Now I'm just going to solve this equation and figure out what y is. So I'm going to combine my like terms. A negative y and a negative y would make negative 2y, so I have 2 minus 2y equals 4. I'm going to subtract 2 and subtract 2. It's going to leave me with a negative 2y equals 2. So I need to know negative 2 times what would equal 2. That means that y is going to equal negative 1. Once I've done that, I'm going to substitute the value of the variable into the other equation and then solve for the other variable. So this negative 1 is now going to go back into one of these equations to solve for what x would have to be. Again, I'm going to use the bottom because there are no negatives. So I would have x plus, and now instead of writing y, I'm going to write negative 1 equals 2. Adding a negative is the same thing as subtracting, so I can rewrite this as x minus 1 is equal to 2. So I need to know what number minus 1 equals 2. That means that x would have to equal 3. So again, my solution would be 3, negative 1, or x equals 3, and y equals negative 1.